Hello, I'm Chip Pickering. I'm the CEO of INCOMPAS, and today I'm very excited as we have a webinar to introduce a new member company of INCOMPAS, Tarana, and to have a conversation with Basil Alwan, who is the CEO and president of Tarana. Now, why is this so significant? You know, INCOMPAS has been founded as the voice for the new entrant, the new technology, the new innovator, the entrepreneur, the new startup, to bring new competition into every market. And Tarana embodies all of those characteristics, and they're doing some really cool things with fixed wireless and CBRS and the technologies that they've developed. And so we're gonna have a chance to really go into depth about this company and what it's doing and the potential and promise to close the digital divide around the country, and why we're just excited to have them as a new member. Let me just real quickly give some background. Basil was the president of IP Optical Networks at Nokia. He managed revenues over $5 billion across IP, transport, cloud data center markets. He joined Nokia through the acquisition of privately held Metro Networks, where he was the founder. So this is kind of a continuing pattern of his life of being an entrepreneurial founder, and in this space, being very innovative. So what we have seen in his past and his experience is the ability to start and grow and build. And so we want to talk about Tarana today and give you a chance to say, you know, why do you believe in this so much? How do you think it's going to close the digital divide? And then talk a little bit more about your background and how it applies to where you are today. And so welcome and thank you.
Thank you, Chip. Appreciate it. Great to be here.
Tell me, you know, on the first question, you know, we're at a historic moment for the industry. The Congress passed a bipartisan infrastructure bill a little over a year ago. $42.5 billion are part of the core objectives coming out of the pandemic. How do we connect every American in every place, urban, rural, whatever market it may be? Why do you think your technology could be an important part of that overall, both private and public commitment to bring connectivity and close to every American and to close the digital divide?
Yeah, great question. Thank you, Chip. You know, thanks for the introduction as well. I started my career a long time ago, but in networking my whole career, starting with advanced micro devices, where I worked on Ethernet chips and all kinds of different networking technologies. And along the way, I've grown an appreciation for teams that know how to innovate and really make a difference. So I got to know Tarana, actually. Your question about the digital divide will come clear because a friend of mine said, hey, there's some guys here next door. I was running, as you noted, this division of Nokia, building really big routers, kind of the terabit stuff. And he said, hey, there's some guys that are making some pretty interesting claims about digital divide and about fixed wireless in particular. And of course, fixed wireless is a really interesting space. It's kind of a bit of a holy grail, home broadband using fixed wireless, because obviously if you can deliver really a good service using wireless, it can speed, you know, how fast we can close the digital divide. It's a great technology to potentially use, but it's been difficult. It's been a very important tool, but it's had limitations because of the sheer bandwidth required for home broadband, especially now with video on demand continuing to, you know, require ever increasing amounts of capacity. So when I heard the story, I said, hey, have the guys over, let me meet with them. And I found this team that had been working for, believe it or not, almost a decade on this technology. And the claims we're making is we can, you know, deliver hundreds of megabits per second, even up to a gigabit per second kind of services in the future using fixed wireless, but even do it in a scalable way, even in unlicensed spectrum. And of course, that is even more interesting. So of course, the first thing I did, I had a series of meetings asking a lot of questions, trying to understand what exactly was the differentiation in the technology. And it culminated actually with, I live in Los Gatos here in Silicon Valley, and even in here in Silicon Valley, there's a digital divide. In Los Gatos up in the hills, there's I have a 5 kilofoot loop, so I get 7 meg DSL. And incredible. The only way I could get, there was no cable, no fiber. We're not dense enough for people to really care about it and run a new service up there. So I was using fixed wireless already, but I was pretty limited. I could get about 20, 30 megabits per second. So they brought up the prototype. After a bunch of meetings, they brought up the prototype, sat on my front lawn, pointed at an experimental tower they had down in Silicon Valley, about 14 kilometers away. And this is running in 40 megahertz of spectrum, so half the bandwidth of the eventual product, which we're now shipping. And I was getting 150, 170 megabits per second with a very nice uplink. So I figured, okay, I got to invest in this company. So I ultimately invested. I joined the board, and when I left Nokia, I chose to jump in here and help out by becoming the CEO of the company. It's been really, really interesting. Tarana is a bit of a unique company in that way. They've got some very deep innovation, more than just grabbing a chip from Qualcomm or Broadcom and building a system. There's a saying I like, which is basically, it takes at least 10 years to make an overnight success, and this company kind of proves that out. So we've really, the company has really developed something somewhat magical here that can deliver very high bandwidth services. Think about, hundreds of megabits per second, 500. Where our customers are offering 500 meg services, 400 meg services, with really nice uplinks, and kind of 100 meg kind of uplinks. And we can do that in a cellular architecture using even unlicensed spectrum.
That is, when you talk about that architecture, why does that, from a technology, economic, investment, efficiency perspective, both help close the digital divide, and then why would you call that a next generation technology?
Yeah, right. So of course, the important thing here is that this technology. So we decided to call it NGFWA, or next generation FWA. All right, that's kind of the category. Every now and then a company comes along and is a bit of a category creator, and I think Tarana would fit that description because before Tarana, for wireless technology to deliver bandwidth to a home or to a business for that matter, line of sight is relatively straightforward. It's not straightforward in terms of deployment because you have to have line of sight. That's the challenge with line of sight technology. But you can deliver very high bandwidth with line of sight technologies, different frequencies. But if you want to do non-line of sight, which is really what you would like and almost need to do if you're going to try to, let's say, blanket a fairly good size, dense area or even kind of a rural area, if you want to use non-line of sight,
yes,
there's only a couple of choices out there right now. There's, in terms of technology stacks, you either have Wi-Fi, which a lot of companies have successfully used Wi-Fi technology, kind of pointed the beam, precisely, and that's what I was using in Los Gatos. And you get a fairly good service over a couple miles. You can get, a service. The other option, the other technology stack is mobile, 4G, 5G. Importantly, neither of those two technology stacks were actually built for fixed wireless. They were built with a different set of, with a different agenda. In the case of Wi-Fi, it was initially built for interior indoor networking. It can be adapted for this, and it has been successfully, but it's not. The fundamentals were not built around fixed wireless. Same thing for mobile, by the way. Mobile is a very sophisticated system, advanced MIMO, beamforming, spatial multiplexing. However, one of the fundamental tenets of mobile is it's trying to communicate with a CPE that is limited on battery life by definition, therefore limited on compute, and also limited on antenna size, which if you're going to try to exploit non-line of sight and mid-band spectrum, antenna size is really very important. So the mobile system is designed in a certain way to do a great job, providing mobile service. There hasn't been actually a technology that from the ground up was designed for fixed wireless like what Tarana has done. So Tarana, this is why this has taken such a long time, this project. The guys who started Tarana actually were a bunch of PhDs and some seasoned veterans that, were experts in the basics, channel modeling, spatial multiplexing, array processing. They, at the theory level, and they built a new physical layer. So a new physical layer, for those who are not steeped in how these things are designed, is kind of the magic beneath the surface that's actually sending and receiving and capturing those signals. And it's pretty hard math, pretty hard stuff. So this company actually innovated at that very fundamental level and built an entire system, top to bottom. Now, what the result of that is, and that's why we call it next-gen fixed wireless, it's not the same as the previous stuff out there. Everything out there right now is based on those two technology stacks I mentioned.
Yes.
The result is when people test our product, they're often really surprised because they've never seen anything behave quite like this. We actually started when we launched our product originally, we launched a kind of a campaign called Seeing is Believing, because everyone would have the same kind of reaction I had to it, which is, I don't believe you. And really, they would literally say, we don't believe your claims. One of our customers, became a really fun story for us. One of our customers actually got the product and was out drive testing. This is smart way in middle America. He was out drive testing the product, and he snapped some pictures while he was doing it. And he had that guy named Brian Grewell. He set the antenna, the remote antenna, on a dumpster, and he was shooting to a tower, I think couple of miles away, and he wrote on the Facebook group, non-line of sight obstruction, tree and building obstructions, 1.5 or 2 miles, 450 megabits per second, and he was really impressed with that, so he posted it on a Facebook group. Then the next posting was the one that we were just on the floor laughing here. He said, turn the antenna around 180 degrees from the tower, 600 megabits per second, and he wrote WTF. And a question mark. And of course, that's when people kind of see, wait a minute, this thing is doing something different. It actually can do non-line of sight, but still have high bandwidth. And there's a lot of, yeah, go ahead.
What do you say? That's the big thing.
Yeah.
Non-line of sight, and it still has the high bandwidth.
Right.
And so it is kind of I don't know if quantum leap, but it is a huge leap for fixed wireless.
It's a huge leap for fixed wireless. It is. And also with interference, which is another really fundamental. Yes. And all of this comes out of the same basic fundamental innovation, which is at the physical layer. If the physical layer, you're more agile to, let's say, do basically beamform, which is pointing energy, but also receiving that energy in a very directional way. And then what's called nulling, or silencing people or devices you don't want to listen to. If you build a different system, you can be much more precise at that. And you say, well, why did the guys that built 5G systems do that? Well, the reason is because that remote device cannot have an antenna and the compute required, because it would burn the battery. So this is a different system design. And with that, we get some really interesting characteristics. And that's a foundation upon which we can build things, including interference cancellation, better multipath. So our spectral efficiency, which is a term used for how efficient you are at using the total channel bandwidth between you and a receiving antenna, our spectral efficiency is meaningfully higher than all other systems in fixed wireless.
And you're using the other, from an economic efficiency point of view, you're using CBRS spectrum and other unlicensed spectrum. So the economics of your deployment with your leap forward in architecture, non-line of sight, being able to cancel the interference, and then your key input spectrum is shared and unlicensed. If you put all of that together, it changes not only the performance, but also the economics.
And you just described NGFWA. That's putting all that together is kind of a leap forward in fixed wireless, what fixed wireless can actually do. And to your point, this technology is really quite adaptable. It can run in licensed or unlicensed, and we do run in both. We run in licensed spectrum, as in CBRS, GA, or PALS. We can run in unlicensed. We can pretty much run we could even run in mobile licensed bands. So the technology is very agile in that way. But the magic of it is that we allow customers to use whatever spectrum they have. And if it's dirty spectrum, let's say kind of noisy, especially with Wi-Fi and in the 5 gigahertz range, we can clean it up pretty well. And that's magic. We have a demo here, which was one of the other demos I saw, which is really impressive, where our interference cancellation is silencing signals that are 20 times, 20 dB more higher power right next to the receiver. Seeing stuff like that, if you're in the engineering field and seeing the effectiveness of it, is really impressive. So it's definitely a really unique technology. It lets us do some things that heretofore were not possible with wireless. There's limits to all technologies. You can't drill through a hill, of course, with wireless, but it does things that surprise people. So what we've got now with NG-FWA is a new tool for digital divide. And you have to, and digital divide is not going to be closed by one thing. It's not just fiber, it's not just satellite, it's not just fixed wireless, it's not just anything. It is in fact a set of solutions that are more appropriate in different settings. And NG-FWA is a new one, a new tool that needs to be added to the set of tools when you're trying to solve a problem in a given area. Economics, geography, spectrum, all of those variables.
That's a good summation on what Encompass is trying to do, and as we advocate in all of the above strategy of all the different technologies and all the different networks and all the different deployments. Exactly. One of those that is very important, not only to our membership, but also to the country's competitiveness and our rivalry with China, is the deployment of 5G. Talk about Tarana in the context of 5G and both contrast or comparison or complementary nature of what you're doing.
Well, 5G is of course a great technology, and it's workable for FWA as well. You can offer fixed wireless with 5G, as evidenced by some meaningful success with T-Mobile, Verizon, and others using 5G technology, not just them, using 5G technology, 4G and 5G technology to offer fixed wireless. So it's actually a quite good tool. The challenge with 5G, or let's say 3GPP standards, 4G, 5G, is a couple fold. Number one, they really don't have the interference cancellation built in to allow the usage of unlicensed, or let's say crowded spectrum. And it's not just that there's a number of benefits to having that interference cancellation technology. It's not just canceling unknown interferers. It's also canceling self-interference. So what do I mean by that? In Tarana's system, because it has this kind of really interesting physical layer, can do some pretty advanced things in canceling self-interference. So if we have a cell architecture, at the edge of the cell, we can pretty much perfectly cancel all of the interference, including ourselves, from nearby cells. What does that do? That allows us to have really high bandwidth at cell edge and consistent bandwidth at cell edge. One of the things about fixed wireless, or let's say about fixed services, customers expect a service that when they hit speed test is always going to be the same. Peak hour, non-peak hour. I mean, there's some variability even in fiber networks and cable networks, but they're going to expect a pretty steady service that's not really highly variable. And Tarana's technology is very good for that in a cellular type architecture. It's a bit more difficult to do that with like a 4G, 5G technology. So we get better spectral efficiency, better performance at the cell edge. It's a better system really for delivering fixed wireless services. That being said, if you're running a mobile network and you have extra spectrum, which is the second big tough issue with 3GPP, or let's say 4G, 5G, is the amount one of our customers gets paid for a mobile bit is about 50 times as much as they're going to get for a fixed bit, because homes use about 50 times the bandwidth, and that's probably going up a little bit further as we get more and more video on demand. So you have to deliver the amount of tonnage, or the amount of bits you have to deliver for the same dollar, is much higher in fixed wireless. Therefore, if you bought spectrum and it's expensive spectrum, where are you going to always put your priority? You're always going to put it on the mobile network. So what in those systems, what's typically done is if you have excess spectrum, you'll use it for fixed wireless. But if you don't, you won't. So it ends up being kind of a tricky thing. Having said that, if you have a mobile network and you've got excess spectrum, it's certainly an interesting thing to do. And one thing I will say that it has been very interesting for us to watch is here in the US, where there's been some great success, some strong success with subs being added to those systems, is it underscores the demand, the level of the number of customers that are underserved and unserved. So it's really interesting to see the results. But we're convinced that if a customer is happy with or is interested in providing fixed wireless services, running off our system versus that is going to yield a pretty clear result. One more important thing I would say is we're compatible with 5G and 4G. In other words, we can sit on the same tower and we can synchronize. And that's very important because we won't disturb the mobile network if we're co-resident.
It sounds like a lot of very smart people, good nerds, have almost solved all of the different challenges of making, mobile 4 and 5G, line of sight, interference, high speed, high capacity work in almost any environment. And so it really, this is a true breakthrough. And you've used the term the end game of broadband.
Yeah.
What do you mean by that?
Yeah, so I think one of the things about fixed wireless has been traditionally is thought of in some ways as a stopgap to get somebody some bandwidth until they can get X, whether that's fiber or some other service, generally fiber. And I think one of the interesting things about being here in the Valley and being an engineer all my life and understanding how this all works is one of the fun things about the era we're in is this kind of underlying technology march in Moore's law and the various tools we have to solve engineering problems. But what comes along with that, which is very interesting, is every now and then technology marches to a point where you could do something you could previously not do. In this case, the remote node that sits on the home where we deliver a service, the amount of compute in that just 5-7 years ago would have been way too expensive to allow for a product like this. So you could have done it, but you would have spent thousands of dollars on that node. And people say, well, why? If you're going to spend thousands of dollars hanging an antenna on a house, why don't you just run fiber or do something else? Of course, it takes longer. But what has happened, of course, is now the technology has marched ahead, and we can put that amount of compute that we need in a pretty small package, pretty low power, using power over Ethernet, just right, and we're getting this crazy result. What's the point? The point is that wireless has now progressed to the point where there's an end game, there's a kind of end game broadband available to us. What do I mean by end game broadband? What I mean is we can deliver hundreds of megabits and going to gigabits and beyond with this technology platform. So right now, our customers are offering generally in their markets, they're offering, traditionally in fixed wireless, you get offers of 100 megabits per second, be pretty good. You might get a 50 tier, a 70 tier, 100 tier, something like that. Our customers are generally offering 100, 200, 400, sometimes 500 megabit per second services in the areas they're offering service. That's a pretty serious service. And for most customers, once they have a service like that, they don't really need to go anywhere. Now, for those who think gigabit's important, and we do, maybe a little bit more marketing than reality if you really get down to it, because the usage of these networks rarely touches those speeds. In fact, just we're going to do an announcement here on September 27th. I would encourage anyone who's interested to jump on our website, which is TaranaWireless.com. You can sign up for the live stream. We're going to announce a couple of things. We're going to announce some pretty interesting customers that have closed the digital divide much faster than they could have anticipated with Tarana technology. It's going to be fun. We have a couple of service providers along with some town councilmen and stuff talking about how they had a problem and found a solution. But we're also going to announce a new product that will get this technology to gigabit, so the service offering can include a gigabit tier. Importantly, even a gigabit tier under RDOF standards, which is super interesting, which means a super high performance uplink. Yeah. And the most interesting thing about this is that this will continue. In other words, it doesn't stop at a gigabit. So what does it all mean? It all means that this tool is not a stopgap to fiber. This along with fiber, this can be an end game technology. Once you have a customer on it, it's very low latency because it's remote, it's pretty close. It feels like a fiber service in many ways if you're on it. I have it at my home. I use it all the time now, and it's quite a good service. And I think it's going to be a long run service, not a temporary service.
Well, that's I was going to ask you try to tease out big announcements to come.
Yeah.
benchmarks, milestones, and so I'm glad that you talked about what was going to happen by the end of September, and as you move toward this march to 1 gig and beyond in capacity and speed, and I really want to compliment and commend. Every now and then we run across a company that really is a game changer. And brings new technology, new capacity, in a disruptive good way. And I think y'all meet every criteria and characteristic and trait of that type of company and technology. Very happy that you've joined. We do have the INCOMPAS show that's coming up in Denver. And I believe y'all will be doing a panel. And so our members will have more exposure to what you're doing and achieving as you deploy in different markets. Before we go to questions, anything else that you really want to emphasize about Tarana, the technology, and the things to come? And if we were to go to policymakers at the NTIA and Congress, and we were to tell your story, what would you want us to say?
Yeah, by the way, we're thrilled to be part of INCOMPAS, Chip, and thank you for commenting on that up front. And we're going to be excited to be at the show and work with all our fellow members. We're a big part of our message would be simply this. I mean, this company, again, this is a kind of a technology true to force. I mean, the guys who worked on this for 10 years really built something magical here, and so there's a lot of pride in that. The team is really excited, but there's nothing quite as let's say rewarding as seeing your engineering project become a commercial success. And so the company is now has an incredible amount of demand for the product. We're having a hard time building enough, which is great. It's a great problem to have.
Tell me the markets y'all deployed in real quickly.
Yeah. So interestingly, by the way, this is a bit global. The company actually started with a partnership, certainly with a number of really key WISP in the U.S., including Whisper, was an early adopter of our technology, and they've deployed a great deal of it. But we have about 180 customers now, believe it or not. And one of our initial customers was actually MTN in South Africa. If you're not familiar with MTN is a massive cellular provider across Africa, 280 million customers. But they wanted a fixed service as well, and they're a wireless company, so they're using us and deploying us pretty heavily in South Africa right now. And we've got a number of other countries in Africa that we're Nigeria, Uganda, that we're Ghana. We're actually looking at moving into with them. We're also now starting to sell in Australia. We also have a nice relationship with a couple of the largest service providers in the UK. So we're starting to be a quite international play. But right now, a lot of our business is also with the wireless internet service providers in the US. There's just a strong demand for those companies to have, let's say, install base of, let's say, a couple thousand or 10,000 or even 100,000 subscribers. And they might have them on older technology that is, as I mentioned, 25x3 or 10 megabit services that serves customers really well for a while. But in order to keep those customers long term, they know they need to move them to a more modern, service tier. So we're getting a great amount of demand from those types of customers. So it's an interesting group. Now, in terms of government and your comment on, our engagement is just starting with policymakers and government. Our announcement on the 27th will highlight some areas where we've had some really interesting successes. A couple of things I would say. Number one, fiber is superb, but there's other technologies that should work in concert with fiber, to solve this problem more quickly and more cost effectively. That's the bottom line, I think, message here to policymakers. Because in the end, what we really want is we want everyone to have access to a reasonably high-speed service that can give them what they need in terms of educational opportunity, in terms of growth, in terms of entertainment, in terms of all the things that we do now on the internet. If the goal is to get that done as fast as possible and as economically as possible, putting this technology in the mix is really, really important.
Well, we welcome that story, that message, and all of the above advocacy that we're doing, because it really extends fiber and markets, and it complements mobile wireless. It solves a lot of problems historically that fixed wireless has struggled to address. And so, again, I just commend you, all of your team, for what y'all have been able to develop over the last decade.
Thank you, Jim.
And now it's coming at a time where the country's commitment to close the divide, connect everyone, is meeting the moment of your technology, or you're meeting the moment of the challenge and the commitment. And so the convergence of the timing and the technology could not be better. And you've arrived at the right time. And we look forward to both advocating for you and telling your story, and hopefully introducing you to a lot of our member companies and others who can partner with you, extend and deploy and use the technology that y'all have helped develop, or you have developed in a very exciting way. So
appreciate that, Jim. Absolutely.
I don't know if we've have any questions, but I do know that we've had a great conversation, and I look forward to seeing you in Denver.
Definitely.
And all the best.
Thank you, Jim.